Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Recursion that we had done, we had solved this question KPC, keypad combination, not keyboard combination. So yeah, so we were given a string which contains numbers and we had to find all the possible combinations of keypads that correspond to those numbers. Okay. So let's continue this series by solving the next problem that we have, which is this get stair paths problem. Okay. So you are given a number n representing number of stairs in a staircase. You are standing at the bottom of the staircase. You are allowed to climb one or two or three staircase in one move. Complete the body without changing signature to get lift of all the paths. Okay. Yeah, so we will modify kind of this question to some extent and try to solve it. So here they have given that we are standing at the bottom of the staircase, right? So and we have to climb up, right? But instead of that, what we'll assume is that we are at the top of the staircase and we have to climb to the ground floor. Okay. So how do you solve such questions? Like let's go through some sample inputs and outputs first. Like if we have the option 3, then we can come down the staircase in the following ways by taking one step at a time, or taking one and then two step, then two or one step, or directly jumping from the third step to the ground. Okay. So yeah, these were all the combinations that we have for 3. So how do you approach these kinds of problems? So there is a general approach that we assume for these problems. So let's say we have some kind of source and destination. So we have source here and we have a destination here, let's say. And there are some intermediary stops between those source and destinations. So here what we are given is that we can have only we can you are allowed to climb or you are allowed to descend one or two or three steps, right? So we'll have some kinds of assumptions, like we have some intermediary stops. Let's say I1 here, and let's say I2 here, and let's say I3 here. So we can reach from source to I1 or I2 or I3, let's say. And from I1 and I2, there are many paths. So let's say you go from source to I1 in P1. This path is P1, this path is P2, and this path is P3. Okay. And then you can go from I3 to D in, let's say, 3 paths. So let's say this is V1, this is V2, let's say this is V3, V4, V5, V6. So how many ways can we reach from this source to destination? So we can reach for I1, we can reach from, first we'll have to go to I1 using P1, and then we have two options. We can either go through V1 or V2. Similarly, for P2, if we have P2 and we go to I2, then we'll have one way, which is W3, through which we'll go to the destination. So how does it relate to our question? Okay, so let's try to have this analogy, and let's try to have this first shifted here, and then we can have a similar approach to solve our problem. So let's say we have we are at the sixth stair, or we have to climb sixth stair, or we have to descend six stairs, right? So we are at position 6, and we can only take we have three possibilities here, right? So we can only take one step, So if we take one step, then we reach fifth step. If we take two steps, then we reach, like this is an intermediary, like the fifth step here is an intermediary stop that we make, right? If we take two steps, then we reach at the fourth step, and if we take three steps, then we reach at the third step, let's say. And we have to reach to the zeroth or the ground, whatever you want to call zeroth stair or the ground. Okay, so how do you reach from fifth step to zeroth step? So one way, like there are multiple ways here, but one way I can see is that we can have 1 1 1 1 1 5 times. Okay, so this is 3 and 2, yeah, 5 times. Or we can have 2 2 and then 1. Or we can have 1 2 and then again 2. Like this is one possibility, right? So we can have any number of such possibilities. From 4 we can reach using 2 2. From 3 you can reach using 2 1 or 1 2 or 1 1 1. Like these are the possibilities that I can see. Like there will be many more possibilities, but just for the sake of this example, I have considered these possibilities. Yeah. So yeah, how do we, like we have found that we have to establish some intermediaries, and this will help us to establish the faith that we have. Okay, so let's go with the regular approach that we have and try to solve this recursion problem. So our expectation is, if we have the get stare path, and if we supply it an input, let's say 3, then it will give us all the combinations to descend from 3 to the zeroth, from the third step to the zeroth step. So first combination is, let's say, the 1 1 1, then we have 1 2, then 2 1, and can I think of some other combination? 1 1 1 1 2. Okay, let's check the solution just to be sure. And then directly 3, we are allowed to take the 3 also, right? Yeah. So this is our expectations, and let's establish some faith. So the faith that we can establish is, we have the we already have solved it for some smaller set of problem. So let's say we have solved it for get stair path of 3 minus, we can solve it for n minus 1. We have solved it for n minus 1, which is get stair path of 3 minus 1 of 2. We already know how to get from the second step to the zeroth step. So we'll have this in EL1. So similarly, we can have, we already, like we establish multiple faiths here. Okay. Let's say we have these combinations, because we can get from, we can jump one step or two steps or three steps. Okay. So let's establish the faith that we know how to get from the second stair to the zeroth, from the first stair to the zeroth, or from the zeroth stair to zeroth. Okay, so it will be hard to imagine this, but okay, so what we can do is that let's establish some expectation that we want it for get stair pass of 4. So let's think about it. How we can get from fourth position to 1. One way is have one step each at a time. Then we have 1 3, then 3 1, comma 2 2, then 2 1 1, 1 2 1, 1 1 2. I can see these combinations. Okay, so how many are there? 1 2 3 4 5 6 7. Yeah, I can see these combinations. Okay, so this is the expectation that we are setting, and now let's set some faith. So we establish the faith that we know how to get from n minus 1 path to 0, from n minus 2 path to 0, and from n minus 3 path to 0. So, so for n minus 1, we'll go from 3 and then 2 and then 1. Okay, so we know all these. So how do you get from this path? Like we know we have established the faith that we know how do you get from here, like from the fifth position to zeroth position. So how will you get from the sixth position to zeroth position? So what we can do is that we can append 1 in front of all these paths to get those paths. So we know how to get from the fifth stair to the zeroth stair. Okay, so we can do it. Let's consider this example. So we can do it using by taking one step each at a time. So it's 5 times 1. So how do you get from 6 step to the 0 step? We can prepend 1 in front of all these paths to get the solution that we want, to get the answer that we want, right? So if we append 1 here, then we'll have 1, 2, 2, 1, whose addition is 6. So we can go from 6 step to 0th step using 1, 2, 2, 1, or we can have another combination which is 1, 1, 2, 1. So 2 plus 2, 4 plus 1 plus 1 is 6. So yeah, we can climb or we can descend in such a manner. And for the second path, what we can do is that we can append 2, because first we are jumping 2, like we are descending or ascending 2 steps at a time. And for all these paths, if we append 2, then we will get the paths that the paths to get from the sixth position to the zeroth position. So if we append 2 here, so it will become 2 times 3, which is 6, which gives us. For the third case that we have here, if we just append 3 in front of all these paths, then we'll get from 6 to 0th position using this intermediate 3. So if we have 3, 2, 1, which is 3 plus 2, 5 plus 1, 6. So we'll get from 6 to 0th position. Similarly, if we append 3 here again, we'll have 3 plus 1 plus 2, which is also 6. Or we can have 3 appended here. So for all these paths, if we append 3, okay, for these paths, if we append 2 for these paths, and if we append 5 for these paths, then we will get all the solutions that we want to go from the sixth stair to the zeroth stair. Okay, or you can put it in another way, like the problem has done. Like if we want to climb from the zeroth step to the sixth step, what we can do is that first we can have the intermediate tree climbs first, and then we can have these paths and just append 1 in front of these paths. In front of these paths we append 2, and in front of these paths we append 3. So that is the solution that we are going to apply here. And yeah, so let's go to the coding part of this. Let me create a class. Let me copy a class instead. Get stair paths, right? So the method signature will be the same. Let's return null for now. So we have established the faith that we know get stair pass n minus 1, n minus 2, and n minus 3. Okay. So what we can do is that we can take an int here. Excuse me. Yeah. So we can have stash minus 1. Can have this in an array list. Let's say AL1. Then we can have 2, 3 such more array list. So this is AL2 and this is AL3. And why have we assumed that? Because in the problem statement it says that we can climb only one step at a time, or two steps at a time, or three steps at a time. So that is why we have established this here. And then once we get all of these, what do? We create a new array list. And then what do? In front of all these paths, we append 1. So we iterate over AL1. Let me have a for each loop here. So 1, let's say. We iterate over the second array list. Let's say S2, and then we append this. And we iterate over the third. And for this it will be AL3. And then we just return this array list AL that we have. Or we can have these names like path 1, path 2, path 3, right? So yeah, once we get from the fit to the expectations in the generalized format, we will have this analyzed in the stack. We draw a stack for some assumptions that we have. Okay, so let's do that. Let me copy this. Erase all this. Let's see, we have this here. Can I reduce the length of this? Okay, let's say we have this here. Okay, and how will we approach this? That's the question that we have, right? So if we see multiple recursive call, so okay, then we had already discussed that we can have an Euler's diagram to solve such kinds of problems, right? So how will we draw the Euler's diagram? So we'll follow a similar approach here. So let's first say that we will start from, let's say, 4. So from 4, uh, mm, okay, let's start from 4. Yeah. From 4, we'll have 3 possible ways. Okay. So from 4, we can go to, if we consider this, then we can go to the third step if we have the first call implemented. So this is the first call that happens. Then again a recursive call will be made, and then we'll go to the second step. So we'll go to 2. Then again a recursive call will be made from this statement only. So if the first line of this gets executed, a recursive call will be made if a first line of this, like this is the first line, right? Let's get this as first, second, and third line, and let's consider all of this as the sixth line, the fourth line, not the sixth. Yeah, with the return statement and all. So when the first line of this call gets executed, we go to 3. When the first line of this gets executed, we go to 2. We have the stash as 2. When the first line of 2 gets executed, we have stash as 1. Okay. Then when the first line of this gets executed, we have stash of 0. So how do we identify the base case? So we can identify the base case if we have reached 0, like the 0th stair, then we have to stop. We don't have to go down, right? And what do we return if we are present at 0? So what are the options that you have if you are present at the 0th step? You have one option there. You cannot say that you don't have any options to go to the 0th stair. So you have one option there. So the one option is that staying on that same step. So for this edge case that we have of 0, we will just return an array list which contains one element, which is empty. But if we get at some negative position, okay, let's say -1 or -2 or -3, then we don't have any option to go to the 0th step, right? We cannot climb up because that's the restriction established in the problem statement that we have. Okay, so yeah. So for those cases, for negative cases where we get -1 or -2 or -3, we will just return an empty array list. Okay. So this is how we will have the first call that we make. Like from 3, you can have 3 or 2 or 1, right? From 1 again, we'll have 3 recursive calls. From 2 again, we'll have 3 recursive calls. -1 will give us 1, -2 will give us 0, -3 will give us -1. For 1, we'll have 3 recursive calls. Again, -1 will give us 0, -2 will give us -1, and -3 will give us -2. For again here, we'll make 3 recursive calls, 2, 1, and then 0. For 2, we'll have again 3 recursive calls. Okay. So we are drawing the Euler's tree for this, Euler's diagram for this. 0 and then -1. So for 1 we'll get 0, -1 and then -2. Okay. Then we'll have more branches here. For 1 we'll have 0, then -1, then -2. Okay. Yeah. So if we see here, there are some edge cases where, so let's identify those edge cases. Like for here, let me change the brush. So for here we have 0, right? Here we have 0, here we have 0, here we have 0, here also we have 0, and here also we have 0. So for those edge cases that we have where we get 0, we will return an array list with one element which is empty, because we have one option to get from the 0th step to the 0th step, which is staying there itself. But if we are at the negative step, we don't have any option to go to the 0th step. Okay. So yeah, let's can try to trace this now, and let me have this brush. Okay, let me have just the brush that we use. Yeah. So if the first line is executed, we go to the third. Like we are moving up the stack here. You try to imagine the stacks here. We have get sp4, then we get sp3, then we get sp2, then get sp1. Then we finally reach get sp0. So what do we return from here? We return an array list which is having one element here inside it. So let's say we can return like this. Okay, like this contains one element. Then we again go down the stack. Okay, we go down the stack, then we execute this line that we have, the second line that we have. Then we get for 1, 1 minus 2 gives minus 1. So for this edge case, or for this base case, we return an empty array left. For this base case as well, we return an empty array left. Okay. So yeah, after this, we come here again. So we go like this, we execute the pre calls or the pre statements in this way. Then we hit the base case, we go up again, then we come down, then we go up again, and then we are finally at the post. Like this is the post area that we have, right? And all this code will be executed in the post area. So let's try to find out what is executed here, what will be returned from here. So for all the strings, for all the array left which are returned from this, for the array list which is returned from the first call will append 1. So we are appending 1 here. Okay. We append 1 here. And for the empty array list, we don't iterate over the empty array list. Like we cannot add 1 or 2. Okay, so we have made a mistake here. And we'll have to correct that. For the second array list, we have to insert 2, right? And for the third array list, we have to not insert, we have to prepend 2 for the second array list, and for the third array list, we have to prepend 3. Yeah. So let's come back to the problem. So we'll append 1 in front of this, we'll append 2 in front of this, but as it is empty, we don't go into this loop itself. And for the third one, we have to append 3 in front of all the elements. So what do we return from this? We return just empty, just return, not an empty, return an array left which is 1. Then we come down the stack. Then we are at the second, when we are at the get scp2, method stack. Okay. And once we come down the stack, we then again execute this line. So 2 minus 2 will give us 0. So this returns an empty array left with uh, with one element, not an empty array left, an array left with one element. Then we execute this third line. Then we get minus 1. So for negative cases, we return an empty array left, right? And then we again are at the post call here. So what do we do? For all the array left one that we get, we prepend 2 in front of them. So we prepend 1 in front of them. So we prepend 1 and we have got this 1 from here. So we prepend 1. Then for the second one, we prepend 2, right? So we'll just prepend 2. And for the third one, we have an empty array list. So we close this array list and we just return from there. Okay. So if you observe carefully, this also gives us the answer. How will you get from the second position to the 0th position? So there are two ways in which you can get from second position to 0. One, using one by climbing or descending one step each at a time. And then there is a second option, like you can jump 2 steps at a time or you can climb 2 steps at a time, right? Yeah. So once we return from here, then we are at the get kpc3 call again. And from here, we go here. Okay. Okay, so we have 3, 2, 1. So this will also branch out. Okay. So this will branch out to 1 minus 1 is 0, 1 minus 2 is minus 1, and then 1 minus 3 is minus 2. Yeah. So we again are at the get kpc3. We have returned from get kpc2 with this value. Then we again climb up the stack for this condition. We subtract 2 and then we get kpc1 and we are again climbing up get kpc0 which returns an array list with one element, and all this will return empty array list. Okay, and then we iterate over we follow this Euler's path. and then we again come down. Okay, so for this post region that we have, we'll have one prepended, so we'll have one here which is returned, and then we again come down and we have 0 here. Okay, so for 0 we return one empty element in the array left, and then we come to the post area of this. So if we come to the post area of this, what happens is we'll have to prepend 1 in front of all of these. Okay, so we'll have 1 1 1 comma 1 2. That is how we'll get, we have to prepend 2 in front of all of these. So we prepend 2 in front of these, like we have got an array left with 1. Yeah, then we prepend 3 in front of these, so we'll have another. Yeah, so this also gives us the solution. We are executing this here because we are in the post area, right? All the code is in the post area. So how do we get from the third step to the 0th step? So we'll have these 4 options: 1 1 1 1 2 2 1 or 3 directly. Then we again come down the stack. Okay, and then we again climb up the stack, and then we follow this Euler's path again, and we can get the solution that we want. Okay, so this is how we'll solve the problem. The only thing mm, which is special about this problem is the base case and the fate that we have set. So the fate that we had set was, we already know the paths from n minus 1, n minus 2, and n minus 3. And then if we know those paths, then for all paths for AL1 we append 1. For all AL2 paths we append 2. For all AL3 paths we prepend 3. Not append, prepend. Yeah. So yeah, let's try to code in this part. So the base case that we have identified were 2, right? So if stairs is equals to 0, then what do? We return an array list. We have to create an array list first. And then we have to insert empty element here. And then we have another else if condition or if condition. If we have this less than 0, then we return an empty array list. Okay, we have to return from here. We have to return array left. So that's the thing, right? The edge case here. So if we are at at the 0th step, we have one option to stay on that step. We represent that by adding an empty element in this. And if we are at the negative step, we cannot climb up. Or if we are at the last step, if we are climbing up, then we cannot climb up more. That's how you can imagine that. Yeah. So that's all for this problem, I think. Are we missing anything? No, right? Let's try to execute it. Okay. Yeah, we haven't changed this, right? So we have to prepend 2 and 3 like we had changed it here, right? Yeah. And we can have enter number of tests. Let's try to run it. So I have 3 stairs. So we have these 4 options if we have 3 steps. Let's try to have 4 steps. Yeah, so let's compare it once with the solution that we have. So we have 1 1 1, 1 1 2, then 2 1 1 2 1, 1 3. Okay, so we missed this 1 3 and 3 1, right? Okay, so this was 3, my bad. 1 3 and 3 1. Yep. Then I have 2 1 1, then 2 2 as well. Yep. Yeah, so that's all for this video. Like, this was a tricky question, but uh, going ahead, we will be careful if we have these kinds of questions where we have a source and a destination, and in between the source and destination we have some intermediate stop, then we can assume that we'll have multiple recursive calls there, and we have to have multiple faiths established at that time. Okay, and the code will be executed on the post area. We'll have more than one in area. So this is the pre area, this is the in one area, let's say, and this is the in two area, and this is the post area for 4 that we have. Okay, yeah, so that's all for this video. See you guys in the next one. Thank you.